Welcome to part 3 of restaurants, food, and music. Last we were talking about calculating the expected counts for our Chi-Square distribution here. So, I did my expected counts, hopefully you did too, and these should be the values you got. So we're going to talk about our conditions a little bit. Now, as far as our conditions go, typical for proportions, you want random, 10% condition, and large counts. Now, as far as 10%, here's the thing. If you're doing an experiment, you have a little bit of flexibility here. You don't necessarily have to be looking at 10% of your population. And also, as far as random, you're going to have volunteers for an experiment. So you're not really randomly picking people. However, we did have random assignment here. So that does fit this. Now, typically, for an experiment, you always want random assignment anyway. But if you're doing a Chi-Square test based on an experiment, then you have a little flexibility with these conditions. However, one that's firmly in place is large counts. You want every category to have greater than 5. Greater than or equal to 5. And you'll notice that we meet that here. Every single one of these is greater than or equal to 5. So in that, again, it's based on expected, not observed. It's okay, because if you'll notice, we have an observed here of 1. That's fine, because we expected 9.57. So, just like a goodness of fit test, what you're going to do, you'll notice I already set it up for you. Take, oh boy, it's really thick, hold on. How about this? Nice, we do observed, minus expected, and you square it. That's where the square comes in for Chi-Square. And then it's going to be over what you expect. And that's going to give you Chi-Square values that you're eventually going to add up. Now remember, whichever one gives you the largest is going to be the largest factor to your Chi-Square statistic here. You notice I did this all out. Hopefully you guys are going to do the same thing. Plug it all in. I'm going to save you some time. You don't have to do all this plugging in. And you should get, if I remember correctly, I think it's 18.22. Really darn close to that. You can double check. It's definitely in the 18 ballpark, like 18.22. So now what do we do with this? Now we need degrees of freedom. That's the big thing. Oh, well, 18.28. I did save it here. I was close. Off by some hundredths. Alright, so we got our Chi-Square statistic. What do we do with this now? Now we know how to use our table and degrees of freedom. We have to figure out the degrees of freedom. Now for a two-way table, for your degrees of freedom, the D of F, what you're going to do is you're going to take if you look in the number of variables for your columns, variables in column minus 1. Oops, excuse me. There we go. And then I'm going to multiply it by, shrink this down a little bit. Whoops. There we go. Number of variables in the row minus 1. And you know what? I'm just going to do some copying and pasting here. Save us some time. Copy. Paste. Boom. Instead of columns, change it to row. So if we look up here, in this case, let's take a look at our columns. We've got, let's see, 3 here, French, Italian, and other for our entrees. We've got 3 for type of music. Ends up being the same in this case. It doesn't always end up being that way. So 3 minus 1 times 3 minus 1 gives me 4. So my degrees of freedom for this Chi-Square test is going to be 4. So I got Chi-Square statistic, degrees of freedom. What I'm going to do now is I already inputted my table here. So I'm going to look for degrees of freedom of 4. Now I'm going to look for my Chi-Square statistic in my table here. And I got 18.28, which is going to be between these two values here. So my p-value is going to be somewhere between 0.001 and 0.0025. Now again, what that's going to represent here is, like say if I put it here, that's the probability of seeing my chi-square statistic or greater. So the probability of seeing a difference like this or greater in this table, assuming that our null is true, we should be seeing that, again, as you can see, very little of the time. We have a very low p-value here. Now, usually for our significance levels, we're going to be looking at a significance level of 0.05, which means anything from here to here we'd consider our rejection zone. So if we're getting a chi-square statistic based on our 4 degrees of freedom here, any chi-square statistic in this range is going to cause us to reject our null. So in this case, let's take a look. We would reject our null since our chi-square statistic is so high. So I'm going to write again, my p-value is from 0.001 to 0.0025, I think it was. Yeah. So now I can write a conclusion. Since my p-value, remember it's a capital P, is less than my significance level, I have enough evidence to reject my null. Reject my null. As I say, if the P is low, reject the hoe. Always makes my class laugh when I say that. Okay. So, what I can say now is, I have enough evidence to prove. I can go back to my null and my alternate up here. So it's good to incorporate that there is a difference in proportion. A difference in proportion So, I've proven here that looks like there is a difference in proportion between the people who are ordering food based on what the music they're listening to is. So, we've just summarized that. So, there we go. We just finished our test here. So, I wanted to run you through a chi-square test involving homogeneity. Hopefully this helps you and this gets you off and running.